So how's everybody doing? Welcome back to the channel, and in today's video we're taking a look at this little 310 bar air compressor that I have sat in front of me here. This little device is all over the likes of Amazon, eBay, AliExpress as well. You can buy them from, and they are for pumping up the air cylinders on pre-charged pneumatic air rifles. This little one I got from eBay. It's actually unbranded, but there's also versions of this from Tuxing and Viva, and it's a slightly more upmarket one than the basic one. This has the power supply built into it, and it also has an auto cut-off feature for the air pressure there as well. The model below this is the power supply is separate, which is a little bit dodgy, and is a manual cut-off. That base model sells for around about £120. I paid £160 for this particular one. You can then start going above different versions of this that have more capabilities attached to them, but obviously the price goes up with that. So I just settled with this one just because I want to do some work on some of the air rifles that involves a lot of pumping up of the cylinders. Now these particular devices have been a little bit naughty in the UK. There's been recalls on them for electrical safety. As a consequence, I've got my little portable appliance tester over here in the corner that I'm going to run this up on to check out its electrical safety. I've also got a pressure gauge there so we can test the auto cut-off and see how accurate that is. That is a little bit different because that only goes to 250 bars, so I have another sensor on here that I'll have to plug into a meter that will go up to 400 bars, so that will be able to take up to the maximum 300 bar that the compressor can deliver. And then after that we'll perhaps have a little deco inside it just to see what the connections are like and the actual build quality. So the compressor itself, you get an instruction manual with it, which is fairly good. To be honest with you, there's a few typos kicking in there, but it's fairly comprehensive and tells you how to set things up, so I'm pretty happy with that, to be honest with you. You also get a DC power lead that plugs into the DC port down at the bottom here, and then you get the standard UK mains lead that plugs into port above, so you can run this from either directly from your car battery or another 12-volt source or the mains. You also get this little bag of spare parts, little moisture filters in here, some O-rings, a little Foster fitting in there, spare valve by the looks of it, spring and some DC fuses, and then you get an actual moisture filter itself here as well that contains one of those little sponge-like filters in it. So what we'll do is I'll just chuck that out of the way and we'll set up the portable appliance tester and we'll give it a zap with that to make sure that it's all healthy. Okay, so we are all set up with our portable appliance tester. This is my old one, it's Q-Tech KT71. It's now obsolete, but it does most of the needs that I have for, really. I don't do an awful lot of portable appliance tests, it's more my own stuff that I take onto sites. We will move this to a class 1 20 amp, as this is a class 1 appliance, and I will need to plug this in. That will always help, won't it? We'll just have a look at this in here. We are a 13 amp fuse inside here. There is no actual mains loading on this. Loading at 12 volts is 300 watts, 350 watts, beg your pardon, but there is no equivalent loading at 220 volts. So 13 amps might be a little bit high. We'll see how we get on with it. We can measure the load with another meter as well if we get that far with this. So it'll be a class 1 test. I need to hold the earth probe onto here, check the continuity. This will just do insulation and continuity. It's actually saying no continuity, 0.13 ohms. So we'll just go through that. So we're greater than 20 meg ohms, which is okay. We're on 0.13 ohms. So the IET guidance for earth continuity is 0.1 ohms, below 0.1 ohms, plus the resistance of the lead, and obviously my test lead here as well. So what I'll just do is spin the camera around so that you can see the screen better, because you probably can't see that. So that's the readings that I get on there at this moment in time. What we'll just do is remove our lead here. So I've put my test lead into the IEC socket at the end there, and we can go again. So it thinks it's off now, which is fine. Can't see a load on there. So we are 0.08 ohms with my test lead, minus the 0.13 is fine, isn't it? That passes. There's nothing wrong with the earth continuity nor the insulation resistance on that, and that's pretty much all there is to testing a portable appliance, other than a visual inspection to make sure that everything does work okay. I will just do, zoom back out again, try and keep it in some sort of picture. I'll just go around a couple of the other spots on here with the earth continuity and just see how it goes. Yeah. 0.12 on that point there, so that's all pretty much okay. We'll go on the base. Let's see where we are. You can see that this is the power supply underneath here that I can see and get onto, so we'll just test at that point as well. No con again, 0.13 is okay. So 20 meg ohms again and 0.13 ohms for the continuity. So yeah, that seems all fine. We'll go on the fan guard. 0.13 again, 20 meg ohms again. So yeah, I'm pretty happy with that. That seems to be all good. So we'll have a shuffle around and I will hook up the pressure gauge and test this auto cutoff feature that it has installed on it. So we'll run some tests on our little compressor here just to see how this cutoff gauge works and that it's accurate against the meter. I've got a calibrated pressure gauge here. I'm also running this against my data acquisition unit here. If we just go down to the bottom here, I have here a 0 to 400 bar pressure sensor. My gauge up here is maximum 250 bar, so I can't test above that with this gauge, therefore I'm using this. I also want to use this to measure against some regulators to see how well they perform in an air rifle, and this will log the data much better than the pressure gauge will. And I've set this up to read bar. If I go to my channel there, measuring off a current channel which is set to range 100 milliamps. This is a 4 to 20 milliamp sensor over 0 to 400 bar. Therefore, to get this reading in bar, I go to my math and I'm using the function there, mx plus b, and I have set m to 25,000. I've had to do that because this measurement works in amps, not milliamps, and then I have to subtract 100 bar from that multiplication to get me the correct value. So that's those there. Go back to the channel, monitor there. So we'll be able to switch everything on. We'll switch on our gauge. At this moment in time, I've set it to 150 bar from what I can make out. So we will switch on our compressor. Let's say cutoff is 150 bar, so you won't hear much as soon as I start this up. Put the fan on and then we'll put the compressor on. I do start these compressors up with the bleed valve in the bottom corner here. I have this open initially just to blow out any dirt or moisture that's collected since the last run. So we'll swing back there so you're on the gauges. Switch the fan on. Fan's on. There you go, we are on 150.5, 105. It does drop a little bit once you've switched off. That's just the way these things work, but that's a fairly comparable reading. Just swing around and I'll blow that out and it should go down to 0. Go back down to 0. I'll swift this around to 200. So that's on 200 now. We'll go again, fan on. Again, stopped at just over 202, I think it was, about when it stopped. Again, we get this little drop, just nothing to worry about. Set it up to 250. As I say, that's the max our little gauge will go to. Good old gauge always cuts off at the wrong moment. So yeah, it stopped, and again we've got this drop, haven't we? So 246, 246, that's all fairly reasonable. I'm quite happy with that. Just get rid of this air again. Yeah, a bit of moisture blowing out there. I'll just unplug our gauge. We'll stick a blank on that, so we can then go to 300 bar, which is the max of any air rifle that I know of, really, and the max on this compressor as well. So yeah, she stopped for there, 297 bar, so that's all fairly accurate. So it's a little bit tricky setting that pressure gauge. I'll show you that in just a moment so you can see how I've been setting that up, but it seems fairly accurate. Happy with the accuracy between my meter set up here and my pressure gauge, so we should all be good to go, and we'll be able to pump a rifle up. We'll also strip this down and our compressor down and have a little deco inside it to see how it's getting along. So what I just want to do is show you this setting needle, because the needle itself is quite thick and it kind of sits over the top of the gauge that we're trying to set it to. I don't know how well you can see. There is a little vertical bar here that comes off of the needle, and it's that when our actual pressure reading needle touches that causes the cut-off. So you can't set the thickness of this to your pressure. You need to set the pressure you want on this little vertical bar here. So if I move this around here, that's 2000 psi that I've set there. But if you look over the top of that, which is going to be difficult to show you, I'll give it a go. So that's the vertical view of our 2000 psi setting. You see it's not overly obvious. It's easier to set this if you look at it from the side and look at the actual prong that's going down. So we know we're working okay. You can see there the alarm is the cutoff there. You have to hit the compressor button again to set it, and then you lose it. But you see it got up to 20 degrees C based upon those few little tests that I did, which is all very good. So I am just going to drop this cover off, at least have a look at the electrical connections inside to see what they are like. I'm just going to take off the outlet and the bleed screw just to make it easier to take the cover off. I'm just going to do those screws around here. No point in recording that, it's just using a screwdriver, which I'm sure we can all do. So that's a couple of screws at the top to take out, and then the cover should just lift clean off. And that's what we're hoping anyway. There we go. Okay, so we have wires on the inside of the lid here to those two switches. You can see the side a little bit more. Looks like we've put some silicone over the connections onto the mains jack there. There's our motor, a little compressor around the back. Yeah, the wires are frayed out on this live. Turn very easily on that. That's what you get for using these kind of terminals and not using any ferrules. So to be honest, for me, for this kind of clamp terminal that you've got, I would use either an eyelet or a fork terminal on that. Ferrule, you can use a ferrule, but it just puts a lopsided force on the clamp as you screw it down, so my preference is to use those, but then that stops these wires from fraying out, so I will do a fix on that. See how we're doing there. So we have removed the power supply here from the unit itself. There is some scoring mark just here and just here, and there's a bit of grease on the actual compressor. Hopefully you can see just there, the power supply that bolts in this section. It butts up hard against this, so brilliant. I imagine this wiggles around. This is on rubber mounts, so this will bounce around a fair bit in operation, so it's going to rub on the power supply here. So yeah, not sure what we can do about that really. Output on this is plus 12 volts, 41.6 amps. So plenty hefty enough for the motor if the motor's 30 amps. So I can crimp them on there, so I think what we'll probably do is just drop the compressor off and just have a look at that and see what it's like inside. I think that's actually the temperature sensor, to be honest. Yeah, that's the temperature sensor there on the end of the motor. So we're just loosening everything whilst it's still bolted in, as that makes life a little bit easier. Actually got a vice to hold the motor in, of course. There's our little compressor out. 4 bolts there. Got a little breather on the cap there. Just mark that up so we know which way it is around, but that shouldn't be a problem, I wouldn't have thought. The other part, so there's all inside bore, hopefully you can see there. Pretty clean, no scoring or anything. It's not bad at all. There's a line there, so that's just where the grease has been coming from the piston, just where it stops. That's no bad. And then there's our piston and all the rings and everything. You don't get any rings. You do seem to get these O-rings, but these piston sealing rings you don't appear to get. But a little bit of light grease on them. Come off my fingers. Piston. Got some O-rings inside there as well. Which are lubed up. You can see where the lube's been stopping at the end of the stroke of the piston. That's not too bad at all, actually. Sure what we've got. I don't know then. Dirt on the casting, I'm not sure what that is there. Don't know about that. Looks like we've got an inner. Looks like we've got an inner piston as well. Not sure how well you can see this. The light isn't brilliant on this. Certainly scoring on those two around there. Not quite sure why that would be there. Be sliding up inside there. Assembled like that. I watched a video from Tilly's Gunstocks. I'll leave a link to it. Where he stripped the tuxing version down of this. And you can see with his, it didn't line up very well on this piston, but you can see here with this one, it's not looking too bad at all. It certainly doesn't seem to be hitting at the bottom of the stroke. And there will be a little bit of play in this because it's not on a guide, it's on an O-ring. It's definitely see a screwdriver in there with something smaller. Yeah, you can see there's clearance at the bottom of the stroke there, so it doesn't seem to have that problem. Seems to be lined up reasonably well. So yeah, I'm reasonably happy with the units. Doesn't seem too bad. I certainly don't think I'd leave it running all on its own. So looks like it's time to start getting it back together then. So these bolts here that hold the compressor together, I have tightened up to 7.7 Newton meters. That's based on an M6 cap screw here, going into this aluminium housing. This housing here is about 3/8 wide, so you've got 3/8 of thread going into the housing there. So I've got this table up here that gives you bolt tightening torques for aluminium housings based upon the amount of thread engagement. And there's my Vera torque wrench, if we can get this to focus, saying 7.7 Newton meters there, which is 68 pounds/inch. You can see we click there, 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 click there. So that is everything all assembled. All I need to do is put the power supply back in and reconnect it all. So when we stripped this down, we did observe the markings on the power supply and the compressor case here where they've been rubbing together. They had put some grease on this end here to stop that. I can't really stop that. I can't space the power supply over to this side enough to create any real gap. So all I've done is took a couple of bits of rubber strip on the side of the power supply here, and then if it does rub against that, it'll rub against this and hopefully not through the casing on the power supply. And then I'll just have to inspect it in a few months' time after it's been running a bit. So I'll pop the power supply back in now, and then we'll be able to reconnect it. So there you have it. We have connected everything all up again. On our live neutral and earth, I've used these little red eyelets here to connect onto them, and then up here on the 12 volts positive and negative, I've used these fork terminals. You can, when you're using terminals like this, these clamp terminals, get these tabbed or flanged fork contacts. I'm not sure how well you'll be able to see them. They've got like little hooks on the end here, and they will hook in past the clamp, and then if the clamp becomes a little bit loose, it stops the wire from actually coming out completely. Unfortunately, I didn't have the right size of these to fit into this, so I couldn't use them without ordering some up. So I've used these the standard forks and the eyelets. Eyelets are a bit awkward to use on this because you've got to take the screw out completely, so a little bit more awkward than fork terminals, but all of these here should all give a good connection now. I've got no concerns over that. So we can pop the cover back on and make sure everything still works. Screws in and we should be away. So we'll just finish off with trying to pump up an air rifle. The air rifle I've got there is at the back. That's the Calibra Gun Cricket 2. If we zoom in, you can see, hopefully, if it focuses, we are on 150 bar there, so I'm going to pump this up to 250 bar, which I've set the output on my compressor to. That should give me 100 bar, say 0.35 litre bottle on the rifle with a 300 maximum bar pressure on it. You can see we've got my key sight there looking at the pressure, so we'll be able to monitor that. And what I will do is stick a timer somewhere, hopefully, and then we'll be able to time to see how long it takes. So we'll switch the fan on. So there you can see we took around about 7.5 minutes to pump up to 250 bar. We stopped just short of that, 245. I think my key sight was on at the time, and the gauge just showed below 250 on the air rifle as well. So that's alright. It got up to 22 degrees C on the temperature gauge on the compressor, which all seems good, so pretty happy with that. I can leave you with this plot here. This is from the DAC 970 that shows you the rate that the compressor pumped the air rifle up at, and I'm pretty happy with that. Whilst it does appear to keep stopping at the correct pressure, I certainly wouldn't want to leave it alone to pump up and rely on that, and it does say in the instructions not to rely on that, to be in attendance with it at all times. It does push out a bit of wet air when you get rid of the pressure in the system. I was quite surprised at that, so definitely needs some sort of a moisture filter on it to stop moisture getting into the rifle. So whilst I had this unit in bits and I traced out the supply, I did realise that the 12 volt input is directly in parallel with the 12 volt power supply internal to this. So if you have this plugged into the mains, like I have here, and it's powered up, you will see 12 volts on this input jack here, and consequently on the crocodile clips here. I've got this meter connected to it. You can see there is 12 volts coming out of it, so you don't want to parallel up both these two inputs really. If I just switch this around, you will see that it's not an issue the other way around. So we are now switched off. Here I have 12 volts coming onto my jacks here, and I'm powered up. You can see there's the 12 volts coming in there, but I'm not getting anything coming out on the mains here. Switch them to AC. Yeah, there is nothing coming out on the mains. So the issue is only when I am powering this unit from the mains. You will see 12 volts coming out on the input jacks at the bottom there. And also we had the issues with the connections on the power supply that we've resolved, and a little bit of vibration against the side of the power supply from the compressor. We'll just have to see how that goes over time, but other than that, I'm pretty happy with it. It seems to pass its electrical tests, seems to be able to pump up and work okay in that scheme of things. So yeah, pretty happy with it. That'll be it for this video. Thanks very much for watching. Hope you found it useful, and I'll see you again in the next one.